Imagine a wolf licking flowers and, in the process, helping plants reproduce. It sounds unlikely, but detailed field studies on highland plateaus discovered that Ethiopian wolves sometimes visit flowers for nectar and carry pollen between blooms. These wolves live in rugged alpine habitats, where certain seasons bring rare floral resources. When a wolf laps nectar or sniffs flower heads, pollen often sticks to its muzzle and whiskers. As it moves to another flower the next day, the tiny grains can be deposited, producing cross-pollination that leads to seed formation in plants that rely on animals for pollen transfer. This discovery changes how ecologists see pollination networks. We think of pollinators as bees, birds, and bats. Finding that a top predator occasionally plays a pollination role shows ecosystems are more interconnected than we assumed. A roaming predator can cover long distances and move pollen across wide areas in a single night or over several days. In remote mountain systems, that kind of long-distance transfer can be important for plants that are patchily distributed across plateaus and valleys. How did scientists prove this? Field teams used a mix of camera traps at flower patches, careful sampling of whiskers and muzzles for pollen grains, and observational studies at dawn and dusk. They found pollen from several plant species on wolves and documented seed set in places where wolves range widely. Seasonal patterns emerged. During dry months when insects are scarce, wolves increased flower visits, showing that the behavior is a flexible response to food availability. Conservation implications are significant. Ethiopian wolves are among the world's rarest wild canids, threatened by disease, habitat loss, and human conflict. If wolves also contribute to plant reproduction, losing them would harm both animals and the plants that rely on long-distance pollen movement. That makes protecting wolves even more important because their role extends beyond predation. Protecting a predator can therefore protect plant communities and the people who use those plants for grazing, medicine, or fuel. Practically, conservationists should protect movement corridors and mosaic landscapes. Overgrazing, land fragmentation, and disease from domestic dogs break connectivity and reduce the opportunity for wolves to act as incidental pollinators. Projects that vaccinate wolves, restore grasslands, and support local livelihoods combine direct protection with benefits for plant communities. Engaging local communities in monitoring and conflict mitigation is key because coexistence is the foundation of long-term conservation. The image of a wolf visiting a flower is also a powerful educational tool. It challenges simple categories like predator and pollinator and invites kids and adults to see nature as a web of many small interactions. For scientists, the finding highlights how much remains unknown about the many roles a single species can play. As research continues, the Ethiopian wolf may become a symbol of unexpected connections in fragile highland ecosystems and a strong reason to protect a whole landscape rather than a single species. If you want to support this work, follow credible conservation groups working in the highlands. Learn how vaccination and community programs help wildlife and people, and share stories that show the surprising ways life is connected. The wolf taught us to look again at who pollinates the flowers on the roof of the world. Thanks for watching. I hope you enjoyed this exploration of the animal world. Let me know in the comments an animal fact that you find interesting. I love to learn new facts. And if you haven't yet, subscribe to explore even more hidden wonders of nature.